Hello everyone, thank you for joining me today. Today we're going to cover our vlog presentation around physics. So to begin, we're going to discuss some basic physics principles and specifically how they apply to weather. Nowadays, the Met Office, along with other Met agencies across the world, use very sophisticated computer models consisting of millions of lines of software to predict the weather many days ahead. These models simulate fundamental laws of physics such as heat diffusion, atmospheric physics, and chaos theory, and apply them to measured data from buoys in the ocean, weather balloons, ships, and aircraft, as well as land-based weather stations. The Met Office is the United Kingdom's National Weather Service. As this quote from the Institute of Physics highlights, physics plays an important role within the profession of a meteorologist, specifically the concept of thermodynamics. Thermodynamics is the study of how particles move at different temperatures and pressures. While this is a very broad concept, there are components of it present throughout weather and throughout the way meteorologists forecast the weather. For example, cold temperatures will produce an area of high pressure, and warm temperatures will produce an area of low pressure. Additionally, a high-pressure system is generally associated with nice weather, while low pressure is generally associated with cloudy, rainy, or snowy weather. Since hot air rises, lower pressure is associated with rising air. When air rises, water vapor within the rising air has the potential to condense into liquid droplets, sometimes forming clouds and precipitation. This reaffirms the association with low pressure producing cloudy, rainy, or snowy weather. It is also important to highlight what occurs when a cold front and warm front converge on each other. When cold air within a cold front runs into the warm air of a warm front, it will also cause some sort of storm or thunderstorm. This occurs because the cold air will push the warm air above the cold front. Once again, this causes precipitation. When a warm front runs into a cold front, then the rising air moving above the cold air will produce cirrus clouds high in the sky. The impacts of temperature and pressure tie back into thermodynamics and show how meteorologists can use thermodynamics to help forecast the upcoming weather. The chaos theory is a scientific principle describing the unpredictability of systems. Heavily explored and recognized during the mid to late 1980s, its premise is that systems sometimes reside in chaos, generating energy but without any predictability or direction. These complex systems may be weather patterns, ecosystems, water flows, anatomical functions, or organizations. While these systems' chaotic behavior may appear random at first, chaotic systems can be defined by mathematical formula, and they are not without order or finite boundaries. Chaos in a system was discovered by American mathematician and meteorologist Edward Lorenz. When Lorenz was modeling weather systems with differential equations, he decided to make small changes to the models that he was using. When he did this, instead of getting the expected close approximation to his first results, the results were much different. The meteorologist's process and forecasting of weather and climate, along with various other natural systems, are subject to the second law of thermodynamics, which states that entropy of an isolated system, not in equilibrium, will increase in entropy over time. Ultimately, the ability to predict meteorological event is tied with the chaos theory. Overall, this has helped meteorologists to understand that when predicting weather, a change in one variable of the forecast can have a big impact on the overall resulting weather. For example, if the initial forecast was based upon a 10-mile-per-hour southerly wind, and the wind changes to a 15-mile-per-hour easterly wind, there will be a large overall change to the weather that was initially predicted. Next, let's discuss the scientific method in action. We'll cover the 4 steps of the scientific method, which are observe, hypothesize, test, and revise. And we'll also discuss an article that we researched explaining how the scientific method was applied to this article. In the article, New Method Facilitates Study of the Effects of Chemicals on DNA, the scientific method is used. By leveraging the scientific method, we are able to have a consistent method to validate theories that are an outcome of the scientific method in action. The article, The New Method Facilitates Study of the Effects of Chemicals on DNA, discusses research that has been done by University of Arkansas physics researchers. In this research, they developed a simple, cost-effective method to study the effects of chemicals on DNA, which has potential to improve the development and testing of life-saving treatments. The scientific method was used during the research in order to validate the method that was being tested. The researchers' initial observation was to provide an alternative to other methods of studying DNA interactions, which are less sensitive or require expensive. Additionally, this alternative method is a routine technique available in most chemistry and biochemistry labs. Overall, the observation was made that the current techniques used to study the effects of chemicals on DNA are not always cost-effective and simple to use. The hypothesis tested was that by bending strands of DNA, the researchers can amplify the effects of chemical interactions so that the effects can be observed more easily. This study demonstrated the concept using magnetism and silver ions. Specific to the testing done for this method, the researchers created their amplifiers from two single strands of synthesized DNA, one with 45 bases and one with 30, so one is longer than the other. The bending that results from this construction places stress on the molecular bonds. Because the bonds are stressed, the effects of the metal ions are easier to observe. The researchers tested their amplifiers using magnesium ions, which are known to have a stabilizing effect on DNA, and silver ions, which are known to damage DNA. After the testing was completed, the following results were revealed. When the bent DNA was exposed to magnesium ions, the researchers could observe that the stabilizing effect of the ions promoted the release of energy in the bent DNA, straightening them. When the researchers exposed the bent DNA to silver ions, they observed that the presence of silver ions affected the ability of the DNA bases to pair up, an effect that was too small to be observed on non-bent strands of DNA. It was also discovered that this testing method could be used to investigate the interactions of DNA in other scenarios. In addition to metal ions, it is likely that our bent DNA amplifiers can be used to investigate the interactions of DNA with our chemicals, including organic molecules and reagents. The researchers said in this paper, in principle, it is even possible to develop our method into a convenient technique for screening DNA targeting drugs. That's a nice little example of the scientific method in action, and just highlighting the scientific method overall, which once again is to observe, hypothesize, test, and revise. Alright, for the next section, we're going to talk about some classical physical principles. The first, we'll talk about airplane flight. And for this example, we'll use a scenario that was given during our modules, and it goes as follows. Mandy took a trip to Rome, Italy. She gazed out over the open ocean, 20,000 feet below as her airplane began its descent to her final destination. She could watch the sun settling in the west. Over the eastern horizon peaked a full moon, just rising, displaying its cratered face. As the plane neared the ground, Mandy could not help but think that she was in a giant metal object hurtling through the sky. Without the specific shape of its wings, the plane would fall to the ground no differently than a large metal projectile. Galileo used a telescope to look at the sky for the first time in 1609. While using the telescope, he found various aspects of evidence that proved that sun was the center of the solar system. This was called the heliocentric model. Specific to our example, the cratered surface of the moon is observed while the plane began its descent to its final destination, is something that Galileo observed through a telescope. Prior to this observation, the moon was previously thought to be perfect. Outside of the craters on the moon, Galileo also observed the phases of Venus, sunspots, Jupiter's moons, and the stars in the Milky Way. All of these observations helped to support the heliocentric model. The fact that from the airplane, Mandy was able to see the sun and moon also highlights one of Newton's laws of gravity. Newton recognized that the moon has enough velocity not to be pulled into the Earth, but is not moving fast enough to escape the Earth's gravity. The same relationship occurs between Earth and the sun. Newton called this type of relationship the inverse square law. The fact that the relationship existed between the Earth and the Moon and the Sun and the Earth helped to prove that the laws of gravitation apply everywhere. Because of this, the same physical principles we study on Earth also apply to the Moon and other planets. Newton's third law of motion is also applied to aerodynamics. By definition, the third law states that for every action in nature there is an equal and opposite reaction. In regards to aerodynamics, lift and thrust relates to the third law. The airfoil on the wing of an airplane controls the lift of the plane. If the air is deflated downward by the airfoil, the wing is pushed upward. Alternatively, if the air is deflected upward by the airfoil, the wing is pushed downwards. The jet engines on the plane produce thrust through action and reaction. The engine produces hot exhaust gases which flow out of the back of the engine. In reaction, a thrusting force is produced in the opposite direction. In both of these instances, Newton's third law of motion is great. Another example is sledding in winter. So there's a picture of my two younger daughters after our first snow. I believe that would have been in, November, quite some time ago, but it's almost all gone now. One of my daughter's favorite winter activities to partake in is sledding. Galileo's discoveries within the physics of motion can be seen when we go sledding. In his experiments using rolling balls on ramps, Galileo discovered the following. Objects slow down as they move up the ramp, and objects accelerate as they roll down the ramp. And objects keep the same speed as they roll along a flat surface. Based upon these observations, Galileo created his principles of inertia. The physics of motion that Galileo studied are observed while we go sledding. Pulling the sled up the hill is slow, methodical work. The sled does not go fast, and it is much harder to pull the sled uphill. We can compare this action to Galileo rolling balls up the ramp. When the sled goes downhill, it goes much faster. The sled accelerates, and no pushing or pulling by me is required to increase the speed of the sled. The fact that the sled speeds up as it goes downhill is also seen in Galileo's experiments. In the experiments, the balls accelerate in speed as they roll down the ramp, much like the sled accelerates in speed as it goes down the hill. Next, we will cover electricity, magnetism, and light. Once again, we're going to use a scenario from our modules, and this one will be specific around the electromagnetic spectrum. Mandy took a trip to Rome, Italy. Once landed and inside the terminal, she turned her cell phone back on, but it was not charged. She found a charging station with a USB adapter port. The USB was universal, providing 5 volts in any country you were in, and small red light next to her phone screen told her that the phone was successfully charging. The USB port seemed to have very high amperage, meaning it charged her phone quickly. She was aware, though, that almost all of Italy's electricity was generated by burning fossil fuels, and thus she was determined after this to use a portable solar charger she had brought rather than wall electricity. The electromagnetic spectrum ranges from radio waves to gamma waves. In our example, Mandy comes in contact with many different aspects of the electromagnetic spectrum. In doing so, we were able to see many ways that Maxwell's research impacts us yet today. When Mandy initially lands, she immediately turns back on her cell phone. Cellular phones operate with radio frequencies, a form of electromagnetic energy located on the electromagnetic spectrum between FM radio waves and the waves used in microwave ovens, radar, and satellite stations. Cell phones do not emit ionizing radiation, the type that damages DNA. It is important to highlight the fact that cell phones do not emit radiation because of the location of the radio waves on the electromagnetic spectrum. Due to Maxwell's research, we were able to feel confident in the safety of cell phones and the radio waves they emit. Once Mandy realized that her cell phone battery was not charged, she decided to plug in her device at the charging station. The red LED next to her phone screen that told her the phone was successfully charging is another example of Maxwell's work in the electromagnetic spectrum. Red LED devices produce light at a wavelength of approximately 633 nanometers. Carrying out the calculation required to find the frequency of the LED leads to a frequency of 474 terahertz, which places it in the red region of the visible electromagnetic spectrum. By properly classifying where visible colors are located on the electromagnetic spectrum, Maxwell helped to determine what frequency each color of light is. Lastly, Mandy has decided that she wants to use her solar-powered battery charger as much as possible on her trip. Solar radiation is made up of electromagnetic energy of various wavelengths. Solar cells are made out of N-type and P-type semiconductor material that use the visual light spectrum to generate electricity. Solar radiation with wavelengths of 380 nanometers to 750 nanometers strikes the material with enough energy to knock electrons from the weak bonds and create an electric current. By using Maxwell's research, we were able to determine what wavelengths along the electromagnetic spectrum are distributed by the sun. We can use this information to properly build a solar panel that can maximize the energy that is absorbed into the solar panel and eventually turned into energy. Personally, I've worked in the cell phone industry for the past 14 years. The research by Maxwell directly impacts my career in the cell phone industry. Throughout my career, there have been many advances in technology that have allowed for additional products, services, and devices to be developed on cellular networks. Most recently, there has been the introduction of 5G networks into the cellular industry. The ways in which various cell phone providers have implemented this technology ties into the size and frequency of the radio waves. Based upon what spectrum licenses that the provider has depends on the way the 5G network will be built up.